All right, let's talk about questions. So I'm gonna start with the one question that's very popular. Was nobody kind of know like what to do with this? Um, I have no idea what is that, but
It is 18.
yeah, do you guys know what to do?
Yes. I don't know if it's right.
Yeah, then that's why you're supposed to check your answer. You have all this time to check your answer. All right, so the thing is that if you know your algebra property, your calculus property, this question is actually very straightforward. But this question even trip up the best students. So why is so hard? So square root x y can be break up to square root x over square root y. That's the identity for the radicals. So you can say that's 1 and 8 and square root 2 over square root x dx. And then you can say, oh, okay, well, square root 2 is constant. So that's going to be square root 2 integration 1 to 8, 1 over square root x dx. So now the question becomes pretty easy because 1 to 8, this is x to the negative 1/2 dx, square root 2. Then what I'm going to do is I'm going to go here. I'm going to say square root 2 times 1. We're going to integrate that. So it's going to be x to the 1/2 times 2. And besides the square root, it's going to be 8 and 1. So it'll be 2 root 2 times square root 8 minus square root 1. Does that make sense?
How did you go from that bottom to
I integrate x to the negative 1/2. So it'll be x to the positive 1/2 divided by 1/2. So it'll be times 2. So that will be, this one is going to be 2 root 16 minus 2 root 2. So that's going to give you 2 times 4 is 8 minus 2 root 2. So this question like looks kind of gross, but it's okay. It's actually not a bad. Next question you guys may have. What?
You do number 21.
21. Maya, which question you want? 21. Yeah, 21 is okay. 24 is fine. So we're gonna do 21 first and go 24. Is that okay? So negative 1 to 0, t to the 1/3 minus t to the 2/3 dt. So that's gonna be t to the plus 1. So it's gonna be 4 over third, 3 over 4, right? Minus t to the 5 over third and 3 over 5 between negative 1 and 0. So if I plug in 0, it's just going to be 0. But I'm going to write it out. And the minus 3 over 4 times 1, negative 1 to the 4/3. And so minus 3 over 5 to the negative 1 to, wait, it's 4/3 or 4/3? Yes, 5/3. So this one's going to go 0, right? And this one's going to be negative. This will be 3, 4 minus. This one's negative. So negative 1 to the 4/3 power. That means you cube root is going to be negative 1. And to the 4th power is positive 1. So that is going to be 3/4. Minus negative 1 to the 3/4. Negative 1 to the 3rd root is negative. And times to the 5th power is going to be negative still. So it's going to be negative times negative is positive. So it's times 3 over 5. So that is 5 over 5 and 4 over 4. So it'll be 20 over 15 plus 12 is 27. Negative, is that right? So if you have negative 1 to the 5th third, it's going to be negative 1 to the 5th power, which is negative 1. So that's why you still get negative 1. So 2 negative becomes positive. Questions? Yes?
Wait, I think it was Ryan next.
Oh,
Could
yeah.
you do
Maya's 23, right?
24?
24 is cool. Okay,
Do 23 after.
I'll do both. I'm start with 23 because slightly easier, but 23 is something you already know. So 23 is something you already know between 0 to 5. Because if a straight line absolute value, then usually just do it geometrically because so much easier. So you can actually just graph it. And this is a 5 or 2. So this is gonna be this area. And 5, this is this area. I know this base is 5 or 2. The height is gonna plug in 0 as 5. This is 5. So it'll be 5 or 2 times 5 times half, and then times 2. So it'll be 25 or 2. This is the one triangle, the other triangle is 2 times. So, but they are the same size of triangle. They can have different size of triangle, so you have to worry about that. Questions? No? Okay, I'm gonna go to 24. Maya's 24, right? So I just go by order. It's not because I answered your question last. So again, I need to know how to graph this. If you know how to graph this, you win. So start by graphing what is absolute value x and what's absolute value x minus 3. What does that graph do if you have absolute value x minus 3? Move to the right and what graph? V shape, look to the right, right? So we know that it starts from here, but move right to the 3 like this, right? So this is absolute value x minus 3. Is that okay? This is negative, means what? What? They flip. So this is a negative x minus 3. Does that make sense?
Doesn't it shift?
Yep, you shift up 3. Good job. So then I'm starting like 1, 2, 3. I know it's facing down, but shift up 3, so it's gonna be like this. And now since we want finding 1 to 4, basically we want to find this area here. And I'm lazy, so I'm just gonna count them because I have graphing paper. So the 6.5. But you can do a trapezoid plus another trapezoid.
Why are you laughing?
The funny thing is that if somebody else, you won't open door for them.
What?
I said if it's somebody else, you won't open door for them.
Well, let me tell you, like, if I was like an immigrant and I had to pass the citizens test, I would fail at least like 6 times.
Really? Is that hard?
Like, it's so, like, you have to know so much details and so much things that. Wait, what did you take? The
Civics exam.
Yeah,
that-
civics, like the civics, like government test. Oh, so like the one that like you have to take like in a scanner. It's like a government, yeah. Like it's easy, but it's like, what amendment was this? What amendment was this? What
I would have failed. I won't pass civic. I'm gonna have to be deported.
like first day Like, I kid you not. Like, I'm not passing.
First day, the earliest flight.
Right.
No, they won't even send you on a flight. They send you on a boat in a container.
How was it for you?
Yeah, that I would have failed. I won't know which amendment's what.
Yeah, I was kind of I was like, well, I was in between like two answers.
Okay, guys, I've seen the kids who passed that, so I've seen like the kids who graduate on stage.
Oh.
You had to pass to graduate.
Oh, you do? No. You have to take it to graduate.
You don't have to pass
You
to
don't have to
graduate.
pass it. But if you do pass this one,
You don't have to.
you don't have to take it in college. So you don't really have to worry about the AP exam.
Okay.
Like the AP exam will give you credits for college. But if you pass this one, you just don't have to take it. It's not giving you credit. Like, it's not giving you hours for college. Yeah.
Yeah, I would have failed that. You'd be like, what amendment? But I passed my citizenship test, which is they just say like, you know, what's
No, I think it's very
what's a like 13th stripe meaning of the flag?
The original.
What is it? What is that?
Huh?
What is that? No, that's not what you mean.
I know. I'm not stupid.
Wait, you weren't born here?
I passed.
You
My
weren't
ci-
born here?
no, I'm not born here.
Really?
What do you think? My English? How bad my English is? Do you think I'm born here?
Because people are like, if people are like raised in a household where it's like,
Oh no.
damn, I wasn't born here.
I was here when I was 15.
You were born.
No. Citizen, I mean, immigrants rise. Where are you going? It's from Iraq. Wars and shit, bro.
He's born when Bush was bombed the heck out of Iraq.
Yeah. Bombs left, right.
Oh, is that really? Is that really the similar years though? It probably is similar
No,
years.
no, no, yeah. We left when the war was happening.
All right. So anyway, yeah.
Wait, what did we do?
32 and 55. Okay, 32. 32 just integration from a pi over 4 to pi over 2 of 2. I swear those ops. Somebody. What'd you say? Okay, so 2 minus cosecant square of x. So if the integration of that is going to be 2x, Mariana, integration of that is going to be cotan of x. So it's going to be plus between pi over 2 and pi over 4. So it'll be 2 times pi over 2 plus cotangent of pi over 2 minus bracket 2 times pi over 4 minus cotangent of pi over 4. I don't know. I think this is a pi plus. What's cotangent of pi over 2? I think 0. Minus pi over 2 and minus what's cotangent of pi over 4 is 1. So that's going to be pi over 2 plus 1.
Oh, is that
32?
32?
Yeah.
I over 2 plus 1. Dang it.
What'd you get?
I got minus 1.
I think this is a plus. I think you're right. This is a plus. So this one is minus 1. This one minus 1. Pi over 2 minus 1. Pi over 2 minus 1. You good? You have homework?
Are you allowed to do like a bracket instead of like the line thing for when you take the integral?
You're not.
Oh.
What are you talking about?
Which question was
The second line.
Yeah, I think you can.
I just draw a straight line. I mean, I don't know why you do bracket, but hold on a second. I think textbooks use bracket. I use straight line. So at this particular question, this one's a particular the interesting because the problem is this one you cannot do it geometrically. Geometrically cannot be done. So what happened is this one I didn't assign, but I'm going to talk about it a little bit. So so this question is the graph's going to be like this. So it's going to be -3 and 3. That's the x-intercept. The y-intercept for the normal graph is going to be all the way down here, but that's the normal graph. The problem is this graph is not a normal graph because normal graph is going to look like something like this. And you cannot use triangle because the line is all curvy, so you can't really figure out the area under the curve using triangles. Like the previous absolute value question, you can do it, but this is x squared, so the line is not straight. So what do you do? So what you do is you need to understand what does the absolute value do to this graph, and how does the thing arrange. So what you can do is you can say, well, it's supposed to come down, but its absolute value is going to go back up. So the graph's going to look like something like this. And it's going to go to 9 units. So it's up here. So it's going to be like this. Does that make sense? Because what a graph used to is come down here. But what absolute value makes the negative part of the graph reflect across x-axis.
But why does the graph like originally go like on the bottom?
Yeah, because x squared minus 9, it just means x squared graph go down 9.
When you plug in 0 to x squared minus 9, you get -9. That's the absolute value of the x. So it's 0, plus.
No, I get why it flips, but like I don't get how people.
It's like regular absolute value, but you're shifting it up.
Oh.
Yeah, you're shifting down.
Okay.
Okay, so now understand that this is the part of how to understand is understand this part of the graph is the normal function. This part is x squared minus 9, which is okay. But what will be this function here? Well, this function is the opposite of the original function. So it's negative x squared minus 9. So when you do integration, it's going to be integration from 0 to 3. The opposite of negative x squared plus 9 here, dx, plus integration from 3 to 4, sorry, 3 to 4 of negative x squared, so it's x squared plus 9, x squared minus 9, sorry, original function. So do you realize this is the original function, this is the opposite original function, so you had to do two separate integral, two separate one. Yes, Maya? This is just a negative original function because original function is supposed to be like this, right? This is what x squared minus 9 graph look like. Now, since the absolute value, you basically put this one the other way. So the other way, it's going to be opposite original function because this is going to be negative of x squared minus 9. Because you kind of think about it, if you distribute, that's going to give you negative x squared plus 9. So which is at 9 is the y-intercept and negative x is facing down. So that's going to give you the correct functions. So that way you can integrate the right way. You cannot, if you integrate from 0 to 4, just like x squared minus 9, without worrying about positive and negative, what happens is this area here gonna cancel with this area because this actually becomes below. Because you're not based on absolute value x squared minus 9. So what you can do, you can break up two separate integral. This one's gonna be the opposite original function. This is gonna be original function because that's same as the original graph. This side?
Wait, never mind.
This side's the original function. This side's the original function. This is the middle part is the opposite original function. Yes. Because they say from 0 to 4. So it's 0 to 3 to 3 to 4. But 3 is the point they cut off from the original function to the opposite functions.
So would you do like two separate ones, like that?
Yep, I have to do one and I have to do the other
The
one.
negatives too?
Yeah.
Okay. Okay.
And that's why if I can do it geometrically, I prefer to do it geometrically, but this one I have no option
Okay.
because the line is not straight.
Right. Okay.
So why'd you? Oh, so you flipped the signs.
Yeah, put a negative sign to the original function. So
Because it's opposite.
yeah. So this one is not on yesterday's homework, but I want to talk about it because this is how you think. Because negative part, if you want to find area and function, you have to figure out what is that actual function in terms of piecewise. Then you can evaluate this. What time we get off here? Okay. So we're gonna talk about today's stuff, which is average value. Yesterday, did we spend some time to talk about average value?
No.
Okay, so I'm gonna talk about average value. Average value is equal to 1 over b minus a, integration of a to b of f of x dx. And what I'm going to do is I'm going to take this, I'm going to color code different, I'm going to color code to blue. So that way you can see what is going on. Okay. What we know about this part is area under the curve, right? Does that make sense? And this is actually we're going to talk about that in a second, but yesterday the video cut off. The cutoff is basically says, okay, think about two numbers divided by each other. Two different numbers divided by each other, and it's going to be another integer. So think about any example. 16 and 4, 10 and 5. Okay, I like 10 and 5 a little bit better because they have different number. Because 16 divided by 4 is equal to 4, so I have two of the same number. So I'm gonna do 10 and 5. 10 and 5. Is that okay? So if you guys know that a long time ago we learned this notations, long division notations, right? And we put a 10 in here and we put 2 in here, right? But we all know the answer. But do you know why the notations that run right angle like that? Like why do you create that L shape? Yes. Yep, that's area rectangle. If you like pay attention, if I do this, 10 is the area rectangle, right? And 2 is on the other side. So therefore 5 is right here. Okay. And that's a good thing to think about because right now we kind of have to use this idea to find out the meaning of average value. First of all, do you guys know why we take integral and we take a definite integral? Well, you can probably, like, this is my job, my problem is I didn't really explain you why we're doing integral because I didn't talk about the application part of it. So let's just talk about application part a little bit. Area under the curve. Why is area under the curve so important? Because imagine, like Laura, how fast you usually drive on the highway?
I don't drive on the highway.
If you would, how fast you would drive?
Oh. 75, 80.
Okay, 75 on the speed limits. Okay, that's fine. So imagine that's 1, 2, 3, 4, 5, 6, 7, 75 like this, right? So that's her velocity is equal to 75 mile per hour, right? That is going to be the velocity of time. And the x-axis is going to be time. So let's just say she drives for 4 hours, right? What is this area under curve representing? What is this area representing?
Well, she's driven over time.
Which is what?
Distance.
Good. You are a genius. This is the distance. because any area under velocity graph is going to represent the displacement. Actually, it's not a total distance, but in this case, it's going to be displacement. If you're taking physics, it's known as displacement. So that's why we need to find area under the curve as of right now. Also, there's other applications, right? But as of right now, an easy application that you can be done in physics is, what if velocity is 75? You can figure out what area under the curve is going to be the displacement. Is that okay? Okay. Then you say, okay, so why do you need it 1 over b minus a? Because if today I say I have this graph, I have this graph here. Boy, I'm hungry. All I hear is Laura eating in my stomach.
Cool. Okay, you have like 10 more minutes. I'm not eating.
Okay.
Oh, what happened to your chips? What chips? I don't have chips anymore. Oh, those chips. Yeah. Okay, thank you. Here we go. I got a little. I'll
Who's
just
going?
wait till your lesson's over.
Oh, okay.
I can wait.
Oh, you drive, right?
Yeah.
All right, so let's just say if I have area on the curve between A to B, and this area on the curve, I'm gonna show as the red part, because we're gonna take this, we're gonna copy this, we're gonna copy, and we're gonna paste. Now, this is one of the most common things to test, so you have to know the formula. But right now, I'm gonna teach you the meaning of the formula. So the area on the curve is this area here. This area is in red, so I'm gonna color code red. Is that okay? Which this could be like, if this curve is a velocity function, it could be a distance that's covered in terms of this amount of time. Now, what happened is I'm gonna draw another things. So what happened is, what if I can create a rectangle? And this rectangle is gonna be blue. And this rectangle is gonna be somewhere around here. This rectangle is gonna be right here. Okay, so this rectangle is right here. So what if I create a rectangle? Right? So the blue part of rectangle is equal to the red part area on the curve. The blue part of the rectangle is equal to exactly area under the curve. How does that work? That works by this actually giving by the height. So I'm going to use this. This represents the height of rectangle area equal to area under the f of x. So the red area is equal to the blue area, and you think about it. If the red area is, let's just say, is 10, right? The red area. Now, if I divide it by the width, and this in this case is, I would say that if this is 5, but it's actually 6 units. Actually, let's just say area on the curve is, let's say 12, right? Let's say if this is 12 units. This is equal to area of the red part. Then I can say, well, if I find the base is 6 units, so I divide it by 6. Or that way we know the height is 2. So this is going to give you the height of area rectangle. So you think about it. If I take an integral of this function, I'm going to get 12. I divide by the difference between a to b, which is the base of rectangle. I will get the height of a rectangle that offer me the same area. Does that make sense?
No.
Okay, fine. If you say area of the under curve is 12, and if I divide it by
The whole function.
the whole function,
Okay.
yeah, and we know the base is 6 units. So if we take it 12 divided by 6, would I find the height of rectangle? Right? 12 divided by 6, 6 is a base of rectangle. Then my height rectangle has to be 2. So we know this has to be 2. So that is the average height of a rectangle is going to represent the same area under the curve. Okay, so that's what the meaning of average value. How much time I have?
9 minutes.
9 minutes, good. So we're going to talk about last part. The last part is probably the most difficult part today.
9 minutes. Got it.
Challenge accepted. Fundamental theorem of calculus. So fundamental theorem of calculus is fundamental. Yep. This one is capital this one is a non-capital f of x between a to b is equal to f of b minus f of a. That's what you did yesterday for homework. But today we're going to teach you the second part. This is called second fundamental theorem of calculus. The second. So integration between a to x, not to a b, of f of x dx, and then I decide to take a derivative after that. I'm gonna get a f of x. You're like, what's that mean? Well, imagine this. If I take a function, I integrate it, and following with derivative. So go back to original function, right? If I take a nail, I hammer it into the wall, and if I take it out, I get the original nail, right? That's it. But the problem is, here's the problem. If you have handyman like me, if I hammer the nail into the wall, if I take it out, that's no longer a nail. It's going to be a crooked nail because I'm not very handy. Okay? Yes, Ava?
Why do we have the d over d of x in front of it if like we originally were finding what f of x was anyways? Like, weren't we doing that in the first place?
Yeah.
Giving us our original function, so why are we putting the d of d of x?
No, I'm just saying we are assuming this. We are taking derivative after we take integral. So, but right now, and trust me, it doesn't make sense right now, and I can't make it sense yet. But I'm just gonna show you the process first. So if I were to integrate of this, which is the black part, if the black part here is integrated, that's gonna give you f of x minus f of a, right? And I'm going to take a derivative of this part. So integrate of non-capital F becomes capital F. And that's equal to, well, if I take a derivative of this, becomes non-capital F, right? Times derivative of x is 1. Minus f of a times derivative of a is 0. So that's equal to f of x. Now, this is a perfect situation. Perfect situation. But in terms of, that's like if you have a very, very good handyman, you hammer it into the wall and you take it out exactly same nail as before. Yeah, because derivative of a is 0. This is a. Now what the question look like? The question could be look like this. F of x equal to integration of x squared. And then square root of x, okay? Now realize my boundary is not a value. My boundary is the x, but this is a constant. But this one, both are variables. So when they have variable, they usually ask you the derivative of it. They usually ask you that. So we're gonna create a function that you might not heard of. It's gonna be square root 1 plus t squared dt. So the whole goal, if I have this statement, I say, hey, can you find f prime of x? That means I have to do what? I have to take a derivative, right? So I'm going to take a derivative of this function of the integral of this. This is the black part. Now you're going to be like, Mr. Ye, I don't know how to take integration of square root 1 plus t squared. Trust me, you can ask BC kids right now. They don't know how to take integration of square root 1 plus t squared. None of them right now in BC know how to take integration of that. So what we can do is we can cheat. T squared. So what happened is we can cheat. We can assume that there's a g of t equal to square root 1 plus t squared. We're going to assume, we're going to make an assumption. Why do we assume? Because we take an integrate, we're going to take a derivative. We know supposedly go back to original function if it's a perfect situation. But this case is not. So what we're going to do is we're going to say, hey, let's do d to the dx here. And let's do still integration of x squared and square root x. And this we're going to call it g of t dt now. G of t dt. Now, we know how to integrate. How to integrate g of t, non-capital G. What am I going to get? If I integrate non-capital G, what am I going to get? Which kind of G? Capital G of x squared minus capital G of square root x, right? If you integrate, notation-wise, if I integrate a non-capital G, it's going to be capital G.
How do you know that?
We stated that before. We stated that if integrate of non-capital F, it's going to be capital F. We did that with fundamental theorem calculus part 1. We didn't do anything different. We're still doing the same exact thing as yesterday. Now it's only parts different. Now I'm going to take a derivative of this function to this. What's the derivative of the capital G? Lowercase g. Good job. You guys are genius. Now, but the problem is there are two layers. There are two bubbles, right? So we need to do is derivative inside, which is 2x. And minus g of square root x times 1/2 x to the negative 1/2. Because now this is not a constant. If it's constant, you will place the lower, it's going to go 0. Because derivative of the inside is going to be 0, right? But in this case, it's not, because this is a variable, so you're just going to plug in s. So now the hard part is just, this is the easy part, actually just plug in. We know x squared, we're just going to plug in the t. We're going to replace the t with x squared. So it'll be x squared squared, right? Times 2x minus 1 plus square root x squared times 1 over 2 root x. So that's going to be equal to 1 plus x to the 4th times 2x minus square root 1 plus x times 1 over 2 root x. So that is the final answer. But basically, I didn't know how to take an integration of square root 1 plus x squared. I assume that's a function. I take an integral. I place the x squared and square root x because the upper bound and lower bound. Now, if lower bound is a constant, what will happen? If let's just say this is 0, what will happen? This part is 0, this part is going to be 0. Or it doesn't have to be 0. It could be like 2. It could be like, if this is 2, then this is 2. But this derivative 2 is 0. So that whole half part of term is going to completely go away. So yeah, so this is f prime of x, and then I figure out f prime of x without knowing how to take integral of square root 1 plus t squared. Usually, if the, let me give you a clue. If the boundary, write it down. If a boundary is a variable, usually they will ask you what's the derivative of that. Okay, see you tomorrow. Bye-bye.
Boundary is a variable. They'll ask for the derivative?
Yeah, they usually ask you to do it.
Thanks.
Really good.
I shut my mouth today.
Yeah, you put away your phone.
Yep.
Hey, that would help so much. This is the beginning.
What?
Not reading your phone today.
This is black. It was even like this too.
Yeah.
No, but look, I have to stand, but I think I just put on my. Oh, no.
Keep a boundary.
Alright.
Stay like that.
I don't want to, but I want to. Okay, I'll put it to that review too. From home.
I turn off the video right now, so make sure it's streaming.
I do have.